Hi everyone, I'm Sarah Zhou, and welcome to my channel. I founded CareBridge, which is a youth-led initiative that aims to bridge the healthcare accessibility gaps around the world. The CareBridge channel is a digital forum where we will discuss how AI can be used to improve healthcare. Today we'll cover how AI can be used to revolutionize allergen testing, and we'll cover more topics in the future. If you're interested, please subscribe and click the like button to support my channel. So today we'll be discussing how AI can be used to reshape allergen testing, which is a field that directly impacts over 30% of the global population. Allergies are not just inconveniences. They can be life-threatening, and traditional testing methods are increasingly inadequate in our fast-paced, data-driven world. Today, we'll explore how AI tackles these challenges head-on by analyzing complex data sets, reducing human error, and personalizing care. By the end of this session, you'll understand not just the how, but also the why. Why this technology is a game changer for doctors, patients, and public health systems. Let's dive in. Before we go into the details, let's look at our agenda today. We'll start by diagnosing the problem, which is the inefficiencies and inaccuracies in the traditional allergen testing. Next, we'll explore AI's toolkit, machine learning, computer vision, and predictive analytics, and how they can address these gaps. We'll then review real-world cases, like how AI identified a surge in sesame allergies years before physicians noticed. Finally, we'll discuss ethical guardrails and the future of wearable sensors and global allergy databases. Today's discussion explores a roadmap to safer, faster, and more equitable allergy care. So let's start with the basics. Allergen testing aims to identify substances that trigger immune reactions, from peanuts to pollen. The most common method, the skin prick test, involves applying allergens to the skin and measuring the size of the resulting wheal. Blood tests detect IgE antibodies, which is immunoglobulin E, a type of antibody involved in allergic reactions and immune responses to parasites, while patch tests check for contact allergies. But here's the catch. These tests rely on manual interpretation. A physician might measure a wheal as 5 millimeters while another calls it 4. This tiny difference could mean misdiagnosis. Blood tests take days to process, leaving patients in a state of uncertainty. Worse, diagnostic thresholds are often based on averages that ignore individual factors like age or ethnicity. Imagine a child avoiding peanuts for weeks, only to learn that the test was a false positive. These aren't edge cases, they're systematic flaws. Now let's explore those flaws in detail. Why do these inefficiencies matter? Let's break it down. First, error rates. Studies show that 15 to 20% of skin tests yield false results. A faint wheal might be dismissed as negative by mistake, or a technician might miss a subtle swelling pattern. Second, demographic bias. Most allergen databases are often skewed toward Western populations. For example, Asian patients often exhibit different IgE profiles for shellfish allergies, leading to underdiagnosis. Third, scalability. Allergy rates are rising globally. Peanut allergies in children tripled in 20 years, but manual testing can't keep pace. Rural clinics lack specialists, and urban centers face overwhelming demand. These aren't just statistics, they're real-world barriers to care. But what if we could augment human expertise with AI's precision? Let's explore how. AI isn't a magic wand. It's a set of tools designed to tackle specific problems. Machine learning algorithms analyze millions of test results to find patterns invisible to humans. For example, they might discover that pollen allergies in Seattle peaked 2 weeks earlier than Chicago due to microclimates. Computer vision, the same tech that powers self-driving cars, can analyze skin prick tests images with pixel-level precision, detecting faint wheals or irregular swelling missed by the human eye. Predictive analytics can take this even further By integrating patient age, location, and genetic data, AI can predict cross-reactivity risks, imagining a system warning a patient with a latex allergy to avoid avocados, a known cross-reactive food. These tools don't replace physicians. They amplify their capabilities. Let's see how this works in practice. Let's walk through the workflow. A physician uploads a skin prick test image. The AI doesn't just measure the largest wheal, it analyzes redness, swelling gradient, and even surrounding skin texture. Simultaneously, it pulls in the patient's demographics, such as a 7-year-old in Arizona with a family history of asthma. Cross-referencing this with regional pollen counts and global allergy databases, the AI generates a risk score. It might flag mesquite tree pollen as high risk, but deem soybean allergies unlikely despite a positive test, citing low regional soybean farm density. The report also warns about cross-reactive foods, like mangoes for patients with birch pollen allergies. All this happens in minutes, not just days. Now let's see this action through practical situations. Suppose a hospital faced a crisis every allergy season: overwhelming clinics, delayed diagnoses, and frustrated families. They partnered with an AI startup to pilot an image analysis system. Previously, technicians spent 20 minutes per skin test, measuring reactions under magnifiers. With AI, images are analyzed in 2 minutes, prioritizing severe cases. Accuracy jumped from 78% to 94% because the AI detected microwheels invisible to the naked eye. During peak season, the hospital partnered with schools to screen 500 students a day, something unimaginable with manual methods. Parents received same-day reports, and follow-up tests dropped by 40%, saving costs and reducing anxiety. This is a blueprint for scalable care. In 2021, an AI model analyzed 100,000 pediatric records and spotted an anomaly. Sesame allergies in toddlers had spiked 300% over 5 years. Physicians hadn't noticed. They were focused on peanuts. The AI traced the trend to increase sesame in snack foods marketed as healthy. By cross-referencing ingredient databases, it found sesame hidden under trends like natural flavoring. This discovery prompted the FDA to mandate sesame labeling in 2023, preventing countless reactions. What's groundbreaking here isn't just the tech, it's AI's ability to connect disparate data points: patient records, food labels, and regional sales data. This is public health innovation at its best. Let's quantify the benefits. Speed. A child with anaphylaxis risk gets results during the clinic visit, not days later. Cost. IgE blood tests cost labs $50 to $100 per panel. AI image analysis can cut this to $25. Precision. Instead of broad advice like avoid all nuts, patients learn that they can safely eat almonds but must avoid walnuts. For a parent, this specificity reduces fear and improves quality of life. For clinics, it means fewer unnecessary referrals. For insurers, lower costs. This is the triple aim of healthcare: better outcomes, lower costs, and improved experiences, all achieved through AI. With great power comes great responsibility. AI models trained on non-diverse datasets can perpetuate biases. For example, darker skin tones may show different reaction patterns, but if training data or training images are mostly light-skinned, the AI could underdiagnose allergies in Black or South Asian patients. Solutions include synthetic data generation and rigorous audits. Privacy is another pillar. Patient data must be anonymized and encrypted, complying with regulations like HIPAA. Finally, transparency. Doctors need to understand why the AI flagged an allergen. Was it the wheal size, a regional pollen spike, Explainable AI builds trust. Ethics isn't a checkbox, it's the foundation of sustainable innovation. The future is even brighter. Imagine wearable sensors that track pollen exposure in real time, alerting you to take antihistamines before symptoms start. Or a global database where a doctor in Nairobi accesses treatment data from Oslo to diagnose a rare spice allergy. In the lab, AI is accelerating CRISPR research to switch off genes responsible for peanut allergies. These aren't sci-fi dreams, they're active projects. For instance, researchers at Stanford recently used AI to design a CRISPR enzyme that reduces IgE production in mice. This convergence of AI and biotech could eradicate certain allergies within decades. Now, what can we do to drive the adoption of AI-enhanced allergen testing? First, collaborate. Partner with AI developers to pilot tools in your clinic. Start small, maybe analyzing skin tests for a month. Second, train your team. AI outputs require context. A high-risk score doesn't replace clinical judgment, it enhances it. Third, advocate. Ensure low-income and rural patients aren't left behind. Push insurers to cover AI-driven tests and lobby for subsidies in underrepresented areas. Innovation without equity is incomplete, so let's build a future where everyone benefits. As we adopt AI, we must prioritize equity. Rural clinics often lack stable internet. Tools must work offline. Sustainability matters too. Training a single AI model can emit as much CO2 as 5 cars. Companies are now using renewable energy for data centers. Finally, governance. Who's liable if an AI misses an allergen? Physicians, developers? Clear frameworks are essential. This isn't about avoiding harm. It's about building systems that earn patient and physician trust. The road ahead requires balance. AI should augment, not replace, physicians. For example, we can start with triage, letting AI handle routine cases, freeing specialists for complex ones. We also need to educate patients because many fear that AI is a black box, so we should explain how it works in simple terms. Finally, we must build feedback loops where physicians flag AI errors to refine models. Lastly, continuing to look for ways to improve how we integrate AI into practical healthcare will help AI become as routine as stethoscopes. In conclusion, AI is transforming allergen testing on 3 fronts: speed, accuracy, and personalization. We've seen how it reduces diagnosis times, cuts costs, and even predicts emerging allergens, but success hinges on ethical practices such as diverse data, patient privacy, and physician trust. Looking ahead, wearable technology and gene editing promise a world where allergies are not just manageable, but even preventable. This feature is not automatic because it requires collaboration across medicine, tech, and policy. Let's be the generation that makes these changes happen. Thank you for your time, and remember to subscribe and click the like button to support my channel. I hope to see you in the next video.